Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fifth question from the mid-year examination which was written in the province of Mpumalanga in the year of 2024. Please do expect a total number of 8 videos since the question paper had 8 questions in total guys. And please guys, do take this seriously, because knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, please do help us grow the channel by just subscribing. Okay, we are answering the financial maths question. First question: how long will it take for an article to depreciate to zero if the depreciation rate is 12.5% per annum? The only guys way that something can depreciate to zero is if that particular asset is depreciating on a straight line basis. Are you together? Because if it's on a reducing balance, it cannot depreciate until zero. Are you together? But if it depreciates on a straight line basis, it can reach zero. So I can simply say A is equal to P 1 minus I multiplied by N, like this over there. How long? Okay. The future amount, guys, will be 0 rands. Are you together? The principal amount you don't know, so let's just write to P. That's 1 minus 12.5%. That's basically 0.125 multiplied by N. Are you together? The only unknown I'm looking for is N. If I divide both sides by P, I'll simply have 0 again, and then 1 minus 0.125 times N. And then whenever I take the 0.125 to the other side, it will be positive. I'll just have 0.125 times N is equal to 1. Therefore, N is just 1 divided by 0.125. 1 divided by 0.125. That's just 8 years. 8 years. So it will take 8 years for an article to depreciate to 0 rands. It will take 8 years. Okay, and then now you're told that Bandile invests 25,000 into a savings account which is earning 7.3% compounded interest per annum. Okay, firstly they want us to calculate the nominal interest rate compounded quarterly, rounded off into 3 decimal places. We are given a nominal interest which is annually. We just want to change it to a nominal interest which is quarterly. So I'll simply say 1 plus I nominal all over m to the power m is equal to 1 plus I nominal to the power m divided by m rather to the power m. The first one is compounded. It's compounded yearly per annum. So that's 1 plus, for compounded yearly, guys, let's make this I to the power 1. But you are given that nominal interest. Let's just substitute it. It's 7.3. It's 0.073 all over 1 all raised to the power 1 is equal to 1 plus I nominal, which is compounded quarterly by 4 quarters in a year. So m is just equal to 4. Okay, so on the left hand side I'll end up having 1.073 is equal to 1 plus I to the power 4 all over 4 all raised to the power 4. All raised to the power 4. The only unknown I have, guys, is that guy over there. I can find the fourth root on both sides. Then the fourth root, on the left hand side, I'll have fourth root of 1.073 is equal to 1 plus I to the power 4 all over 4. Whenever I take the 1 to the other side, I have the fourth root of 1.073 minus 1 is equal to I to the power 4 all over 4. Therefore, I to the power 4 is just 4 multiplied by the fourth root of 1.073 minus 1. 4 multiplied by the fourth root of 1.073 minus 1. This is just 0.0710826727. Therefore, the interest rate compounded quarterly, the rate, just take this guy over there, multiply it by 100, you'll simply get 7.12. Well, they set into 3 decimal digits, so that's basically 7.018 then. 7.108%. That's how, guys, we're supposed to deal with this. Then now we are told that using effective rate of interest calculates how much money will be in the account after 66 months. Effective rate of interest, ne? Whenever, guys, your amount is compounded annually, it's the same as your that means your interest is simply equal to the effective interest, ne? So I can simply say A is equal to P 1 plus I effective multiplied by N. The amount of money is 25,000. 1 plus 0.125, that's 12.5%, right? Multiply, I have 66 months. 66 months, guys, is just, if you say 66 divided by 12, you'll simply get 5.5. Let me check. 66 divided by 12, that's 5.5 months. Years, rather. That's 5.5 years, ne? Remember that, guys, I must always use years if ever I'm calculating using Ilendole, the effective rate of interest. Why? Because effective rate of interest simply means that interest is just calculated once a year. 25,000, 1 plus 0.125 times 5.5. The final answer will just be 42,187 rands 50 cents. The amount of money that will be there after 66 months is basically 42,187 rand 50 cents. Okay, Zanele wants to give each of her 2 kids 100,000 in the year when each is 18 years old. Okay, they will be 18 years old in respectively 3 years and 5 years from now. So that means one of Zanele's kid is 15 right now, and another one is 13 years old right now. Ne? She wishes to give each of them 100K whenever they turn 18. Okay. Okay. To be able to do so, she immediately invests an amount in her savings account at 6% per annum compounded monthly. How much must they invest now? Round off your answer. Round off your answer in the nearest 100. Okay. I want to know how much must Zanele invest for both kids. For both kids, ne? For the first one, the one who is 15 years old right now, the future amount I want to have in the bank account is just 100,000. I don't know how much I should put in right now, but I know that interest is calculated. What's the rate of interest? 6% compounded monthly. That's just 0.06, because we'll just divide the 6 by 100, né? And then our M, since it's compounded monthly, we have 12. And then N is just the total amount of times interest will be calculated. Are you together? So you simply have 12 multiplied by the number of years. For this kid to reach 18 years, this kid will reach 18 years in 3 years time. So just multiply the 12 by 3, you'll simply have 36. So therefore, you'll simply say A is just equal to P 1 plus I to the power N. For me to find the P, because I'm looking for P, right? For me to find the P, I just need to say P is just equal to A all over 1 plus I to the power N. So A is just 100,000. That's 1 plus 0.06 all over 12 to the power 36. 100,000 divided by 1 plus 0.06 divided by 12 to the power 36. So for the 15-year-old kid, Uzanele must invest 83,564 rands 49 cents. Let me not round off. This is the total amount of money that Uzanele should invest right now if she wants to have exactly 100,000 whenever the kid gets reaches 18 years. And then for the 13-year-old kid, yes, the amount is still 100,000. The amount is still 100,000, right? That's 10,000. I don't know the amount of money that Uzanele should invest so that it will be 100,000 in 5 years time, right? The interest is still 0.06. Should I say divide by 12? Because I did divide it by 12 over there. And then M is just to 12. That means the number of times interest will be calculated is just it will be calculated for 5 years and every month. That's just 60 times, né? So I know that A is equal to P 1 plus I to the power N. Therefore P is basically A divided by 1 plus I to the N. That's just 100,000 divided by 1 plus 0.06 over 12 to the power 60. All over 12 to the power 60. That means for the 15-year-old kid, Uzanele should just invest 74,136 rands. Should I say 30 cents? Okay, 21962. This is the exact amount that Uzanele should invest. For the one who is turning 18 in 5 years time, she must invest this amount of money. And then for the one who is turning 18 in 3 years time, obviously the amount of money has to be more. Okay, and then now you're told that Nathan deposits 50,000 into a savings account earning 88.4% per annum compounded quarterly. After 2 years, the interest changes to 7.9% compounded half yearly. How much money will be in his account after 5 years? So over here, guys, only a few things happen. Né? There's T1 and T7 all together, and then at T2 the interest changes. over here the interest was simply 8.4% compounded quarterly when M is 4, and then over here the interest changes to 7.9% when compounded half yearly. For half yearly, guys, M is just equal to 2. So all you have to do now, guys, is to simply use our compound interest formula to find the amount of money that Uzanele will have, or that Nathan will have rather. Nathan deposited 50,000, and then for the first 2 years the interest will simply be 8.4%, that's 0.084 compounded quarterly for the first 2 years. I'll simply say this will be 4 multiplied by 2, and then multiplied by 1 plus 0.079 divided by 2, and then how many years are there from the beginning of the 3rd year to the end of the 7th year? That's just 5 years, so I'll simply say 5 times 2. So this will simply give me the amount of money that Nathan will have in 7 years. That's 50,000 multiplied by 1 plus 0.084 divided by 4, all raised to the power 8, multiplied by 1 plus 0.079 divided by 2, all raised to the power 10. So the final answer is just 86,980 rands 30 cents. This is the amount of money that Nathan will have. So guys, for June exam, your financial maths that will simply write about it will be grade 11 financial maths. Please do visit your grade 11 financial maths. I think it will be very, very helpful for you, because there's nothing that screams grade 12 financial maths over here. And I've noticed the pattern, because I've answered the Gauteng question paper, the KZN question paper, and I think the Free State question paper has the same thing as well. So please do visit your grade 11 finance. Okay, bye.